In our last video, we explored natural numbers, whole numbers, and their negatives. But what about the numbers between them? Welcome to episode 2. What are real numbers? Today we'll explore fractions, decimals, and beyond. Let's start with a simple question. How do we share a pizza? If we split one pizza between two people, each person gets 1/2, or 1 divided by 2. Every fraction has two parts. The top number is called the numerator. It tells us how many parts we have. The bottom number is the denominator. It tells us how many equal parts the whole is divided into. So 3/4 means we have 3 parts out of 4 total parts. Fractions fill the gaps between whole numbers on the number line. Between 0 and 1, we can find 1/4, 1/2, and 3/4. In fact, there are infinitely many fractions between any two integers. Decimals are just another way to write fractions. 1/2 equals 0.5, 1/4 equals 0.25, 3/4 equals 0.75. These numbers are called rational numbers, represented by the symbol QE. A rational number is any number that can be written as a fraction, where the denominator is not 0. This includes whole numbers like 5, which is really 5/1, negative numbers like -3, and even repeating decimals like 0.33 repeating, which equals 1/3. Some fractions create repeating decimals. 1/3 equals 0.3, repeating forever. Even though they repeat forever, they're still rational numbers, because we can write them as fractions. But here's a puzzling question. Can all decimals be written as fractions? Let's try with the square root of 2. Can we write it as a fraction? No matter how hard we try, we can't find integers that work. It's impossible! The square root of 2 appears in a simple right triangle. If both legs are 1 unit long, the hypotenuse has length square root of 2. Using the Pythagorean theorem, 1 squared plus 1 squared equals square root of 2 squared outside. The decimal value is approximately 1.41421, continuing forever with no pattern. This makes it impossible to write as a simple fraction. Another famous example is pi by 2. Pi is the ratio of a circle's circumference to its diameter. No matter what size circle you have, this ratio is always the same. Pi equals approximately 3421592, but the digits go on forever without repeating. There are many irrational numbers. Square root of 2, square root of 3, pi, p, phi. All of these are irrational. Irrational numbers are numbers that cannot be written as fractions. Their decimal representation never ends and never repeats. There's no pattern at all. Let's compare rational and irrational numbers. Rational numbers can be written as a fraction. Irrational numbers cannot. Rational decimals either end or repeat. Irrational decimals never end and never repeat. Both types are essential for mathematics. Now we can define real numbers, represented by the symbol R. Real numbers are all rational numbers plus all irrational numbers combined. Every point on the number line represents a real number. The integers are there, marked at whole units. Fractions fill the spaces between integers. And irrational numbers like square root of 2, e, and pi fit in their exact spots. Together, they form a complete, continuous line with no gaps. Let's see how we built our number system. We started with natural numbers, 1, 2, 3. Then we added 0 to get whole numbers. Adding negatives gave us integers. Adding fractions created the rational numbers. And finally, adding irrational numbers completed the real number system. Each step expanded what we could count, measure, and calculate. But mathematics didn't stop there. Consider this impossible question. What is the square root of -1? Try any real number. 1 squared is 1. -1 squared is also 1. 2 squared is 4. 0 squared is 0. No real number squared gives us -1. So mathematicians invented a new number called I, the imaginary unit. By definition, I equals the square root of -1.I. This means I squared equals -1i. Now we can take square roots of negative numbers. Imaginary numbers form their own number line, perpendicular to the real number line. Together, they create a two-dimensional complex plane. The horizontal axis shows real numbers. The vertical axis shows imaginary numbers. Complex numbers, represented by C, combine real and imaginary part. A complex number is written as a plus bi, where a is the real part and bi is the imaginary part. Examples include 3 plus 4y, 2 minus of I, and -1 plus 2i. Even real numbers are complex numbers with imaginary part 0. On the complex plane, we can plot any complex number. The number 2 plus I is 2 units right and 1 unit up. -2 plus I is 2 units left and 1 unit up. The distance from the origin to each point is called its magnitude. Here's the complete picture of our number system. At the top, we have complex numbers, the most general type. Complex numbers split into real numbers and purely imaginary numbers. Real numbers contain both rational and irrational numbers. Rational numbers include all integers, and integers contain whole numbers and natural numbers. It's a beautiful hierarchy, with each level building on the previous one. Complex numbers aren't just mathematical curiosities, they're essential tools. Engineers use them to analyze AC circuits and signal processing. Quantum physicists need them to describe wave functions. Computer graphics rely on complex numbers for rotations and fractals. Aerodynamics uses them to model fluid flow around wings. They're everywhere in modern science and technology. Let's recap our number journey. Natural numbers are for counting. 1, 2, 3. Whole numbers add 0. Wow. Integers add negative numbers. Rational numbers add fractions. Real numbers add irrational numbers like pi and square root of 2. And complex numbers add imaginary numbers. From simple counting to the complex plane, each expansion opened new possibilities in mathematics. But wait, there's even more. Beyond complex numbers lie quaternions, octonions, and hypercomplex numbers. But that's a story for another day. Thanks for watching. If you enjoyed learning about real and complex numbers, please like this video and subscribe for more math content.